Why do some apps feel instant while others feel sluggish, even with the same internet connection? A lot of the time, it's not the network, it's the API design choice made months earlier by a back-end engineer. An API is how two pieces of software talk to each other. REST, GraphQL, and gRPC are three different approaches to structuring that conversation, and they make fundamentally different trade-offs. Think of it like ordering food. REST is a fixed menu. You ask for dish number 7, you get exactly dish number 7, nothing more, nothing less. GraphQL is a custom order. You describe exactly what you want and the kitchen assembles it. gRPC is a private intercom between the kitchen and the prep station. Fast, direct, not designed for customers at all. This decision gets made early in a project and almost never gets revisited, which is exactly why it causes problems later. A team building a mobile app with REST starts noticing their users' phones are making 6 API calls just to render one screen. Each call returns way more data than the app actually needs. That's called overfetching. Meanwhile, sometimes one call doesn't return enough, so the app makes a second call immediately after. Underfetching. Both problems burn battery, slow load times, and inflate cloud costs. On the other side, a team that picks GraphQL for internal microservices, services talking to other services at high frequency, often finds the overhead of parsing flexible queries kills their latency at scale. The wrong API choice doesn't break your app on day 1. It slows you down on day 300. REST, representational state transfer, is built around resources and HTTP verbs. You have a URL like /users/42, and you hit it with get to read, post to create, put to update, delete to remove. The server decides what data comes back. You get the whole user object whether you need 2 fields or 20. REST is stateless, meaning every request carries all the context the server needs. There's no memory between calls. It's simple, widely understood, and every HTTP client on the planet supports it out of the box. GraphQL works differently. Instead of multiple endpoints, there's one, typically /GraphQL. The client sends a query, written in GraphQL's own syntax, that describes exactly which fields it wants. Ask for a user's name and email. That's all you get back. It's the client driving the shape of the response, not the server. This makes it powerful for complex front ends where different views need different slices of the same data. The trade-off is that the server needs a schema, a typed map of everything queryable, and resolvers that handle each field. There's real overhead to set that up, and caching becomes more complicated because every query can be unique. gRPC, Google Remote Procedure Call, is a completely different mental model. Instead of thinking about resources or queries, you think about calling functions on a remote machine. You define a service in a file called a protofile, short for protocol buffers, which describes the functions available and the data types they accept and return. gRPC compiles that into code in multiple languages. Requests are sent as binary, not text, which makes them dramatically smaller and faster than JSON. It runs over HTTP2, which supports multiplexing, meaning multiple requests can travel over a single connection simultaneously. This is why gRPC dominates internal microservice communication at companies running at scale. And if this is the kind of thing you want to understand at the architecture level, Stack Future covers one concept like this every day. Imagine you're building a social app. The profile screen needs the user's name, avatar, follower count, and their 3 most recent posts, each with a like count. With REST, that's potentially 3 separate calls. Get/users/ID. Get/users/ID/followers. Get/users/ID/posts. 3 round trips, 3 responses, most of the data ignored. You migrate the profile endpoint to GraphQL. 1 query, user, name, avatar, URL, follower count, posts, limit 3, each with like count. 1 request. The response is exactly the shape of your UI. Load time drops. The mobile team stops filing tickets about slow screens. Meanwhile, the notification service talking to the user service 1,000 times per second stays on gRPC. Because those are internal services, the payloads are tiny, and binary serialization over HTTP2 keeps latency in single-digit milliseconds. 3 APIs, 3 different jobs, all running in the same system. REST is the default, stateless, simple, universally supported. GraphQL is for complex front ends where clients need flexible data shapes. gRPC is for fast, typed, internal service-to-service communication. No single one wins. The right answer is knowing what each one actually does. If this one clicked, hit the like button. It tells the algorithm this is worth showing to more people. Next up, how Kubernetes actually works, explained the same way.